Alright, this is 8.4 part 1. We are going to be solving for variables in quadratic equations. So these are word problems where they're going to give us a formula for something. A lot of times they're like a physics formula. And we're going to pick one variable and get it by itself. And it's going to involve quadratic things, so like squaring or square roots is probably going to be involved. So in the first one, I'm going to kind of condense like all the words on the example. So if you guys can picture, you know, like a pendulum swinging back and forth? Like this, like on a clock or something. So if we're talking about the time it takes a pendulum to swing back, forth, that's what we're talking about here. How long does it take to go boom, boom? This is an equation for that. So it's T equals 2 pi times the square root of L over G, and I'll tell you what all these things mean. It like sometimes in physics certain things are capital, and in this case the T was capital, so I put a capital on here. So T is the time in seconds. L is the length of the swing. And G is Earth's, this is weird, I know, gravitational, and I'll move for a second, constant. So you guys probably haven't used that yet, this Earth's gravitational constant. But there's a number, and it represents the pull of gravity on the Earth. And it's a constant as long as you're on Earth. On different planets, it's going to be a different number. So it's how much or like how fast is Earth pulling stuff toward itself. That's kind of what it means. And for now, we don't even need to know what the number is. There is a number for it, but we're just going to try and solve for one variable right now. So we're not even worried about what any of these things are right now. Yeah? In math, you want to write L in cursive, otherwise it's like a 1. Well, like I was saying, for some reason, certain letters are capitalized in some problems and sometimes they're not, and this one is lowercase. So, I mean, I'm not going to take off if you capitalize it, if it's easier for you. But I'm just saying this is how they do it in the book. So this is the time it takes for a pendulum to swing back and forth. You can plug in the length of the swing. You can plug in Earth's gravitational constant. Or if you were like on the moon, you could plug in the moon's gravitational constant and see how long it takes the pendulum to swing on the moon. Yeah? Well, so anytime you're going to have a pi in it, what kind of shape do you think might be involved? A circle. Because pi is a number that has to do with circles. I'm afraid I'm going to say it wrong. Isn't it it's the circumference divided by the diameter, I believe, right? The ratio of the circumference to the diameter. Let's double check to make sure I'm right about that. But since pi, this is hard to do. Let's type this in. What is pi? Pi is, that's not what we wanted to know. Oh, shoot. Where do you see that? Oh, yeah. The ratio. It's the ratio of a circle's circumference to its diameter. So if you take any circle, so you asked about this, are you listening? So if you take any circle and we measure the circumference around the outside and divide it by its diameter across the middle, you're always going to get 3.141592653589793. We should. Maybe we'll do that. We'll test it out. So anytime you're involving some kind of circle, you're going to have a pi in it. And so if you think of that pendulum swinging, can you kind of see how it's going to be kind of like an arc that it's making, like kind of part of a circle? So that's why a lot of them have pi in it. So on this equation, what we're going to want to do is we're going to want to get, what letter did I want to get by itself? Solve for G. So write that down underneath or to the side. Solve for G. I kind of feel like making sure you guys know your numbers and then having you guys help me up here. Maybe I'll do that. Do you guys know your numbers? I'm gonna tell you them. If you're not sure, I'll tell you them. You are. All right, ready? I'm gonna go fast. Jack, you're 1. Elise is 2. Cameron is 3. Lauren C is 4. Charlie 5. Olivia D 6. Jeb 7. Anya's 8. Cohen's 9. Audrey's 10. Brenna's 11. Jamie's 12. Connor's 13. Sweat is 14. Tyler's 15. Fiore's 16. Liv is 17. Carson's 18. Jake is 19. Clay is 20. Esther's 21. Ella's 22. Lauren's 23. Macy's 24. Zach's 25. Avery's 26. Olivia S is 27, McGill's 28, Piper's 29. Okay, so you know your number. Know your number. Write it down if you're going to forget. We use those a lot more in my 8th grade math class. So we're going to try and get G by itself in this equation. Okay? Trying to get G by itself. So we want to think of, I'm going to call numbers to have you guys help me because these notes aren't very long today, so I want you guys to help. If we're trying to get this G by itself, I want to know what should I get rid of on this side first and how should I get rid of it? That's what I'm going to ask. I'm going to draw a number and ask it. Honestly, if you're not sure, just take a guess. Just take a guess. Just take a guess. We want to see what to get rid of. We're trying to get G by itself. So let's get everything away from the G. Start with the easier stuff. Get rid of the easier stuff first. Who was a guess? Or number 8. Who's number 8? I just told you guys your numbers. Anya is number 8. Anya, do you have a guess of what you would get rid of on this side first? Divide by 2 pi. She's exactly right. So if something is in a square root and we're trying to get it by itself, worry about that last. So first we're going to get rid of the stuff not in the square root. So we're going to divide each side by 2 pi. And if you want to write your pi with a straight line on top, that's fine. I usually do it when I'm working out problems. Divide by 2 pi. So on this side, 2 over 2 is 1, and pi divided by pi is 1, even though it goes on forever. If you divide it exactly, it goes away, sort of. It cancels out. So on this side, we're left with our t over 2 pi. And on this side, we just have the square root left. All right, so keep in mind we're trying to get G alone. We're trying to solve for G. So I'm going to ask the next person what to do next. Number 15. 1, 5, 15. Who is it? Tyler? All right, Tyler, what do you think we should do to get this G by itself? I'll give you hints if you're not sure, but what do you have a guess? Multiply by L over G. Oh, I see what you're saying. Maybe. All right, with some help, we want to get it out of this square root, right? So let's square it. Square both sides. Nice. So if something's in a square root we want it out, we can square it. Because a square root and a square are inverse. So on this side, we've got, let's go ahead and apply that square. So what's t squared? T squared. And then on the bottom, what are we going to have? 2 pi all squared. And we can square both of them, right? Because it's a product. So we're going to have 2 squared, which is 4, and you don't want to figure out what pi squared is. Just write pi squared. That's fine. Even though pi is a number and we could square it, you can just write pi squared. On the other side, we've got, what's left on the other side? Yeah, L over G. Okay, now here, this is tricky. We're trying to get G by itself, and G's on the bottom of a fraction right now. So I'll give you a hint. I'll just give you a hint. Like, that is a bad thing right now, and we don't want that. So think about what you would do. Number 28. It's McGill? Okay, this is a tough one. Do you have any ideas, McGill? Let's multiply G. Nice, McGill. Let's multiply by G. So now, G is not stuck on the bottom of a fraction, right? He's over here now. He's got some other stuff with him, but at least he's not on the bottom of a fraction, right? So now we've got g times t squared, and we can put this, since it's multiplying, we can put it all in one. Gt squared over 4 pi squared. And what are we left with on the other side now? Just our L, right? There's only one more thing left to do to get this g by itself. We are solving for g. I know, but it was stuck in the bottom of a fraction, so we couldn't really well then we'd have L squared over g, you know? He would still be over there. I don't want to know what to do next, but I mean, did you guys have other questions on what we could do right here? Is that what we're stopped at? Yeah? Oh, because right now this is just like you can think of it as g over 1, and so when you're multiplying fractions, you just multiply straight across. So gt squared over 1 times 4 pi squared. All right, so now we're trying to get this g by itself, so I need to get rid of this other stuff. Okay, so if in case your number is called, think about what you would do. So I'll give you a hint. It could be something like this. Think about how you would get rid of like 2/3 from the g. Okay. Number 22. Who's 22? It's Ella? Okay, Ella, do you have an idea for how we could get this g by itself? Yeah. Multiply by something. Multiply by 4 pi squared. Do you want to multiply by anything else while we're doing that? Where? Nice. So we're multiplying by that. Do you guys remember what that's called? It's called a reciprocal. We're multiplying by the reciprocal. 4 pi squared over 4 pi squared is 1. T squared divided by t squared is 1. As long as we multiply this side by 4 pi squared over t squared. So now, what's left over here? G, that's exactly what we wanted. So G equals, let's put the 4 pi squared L over t squared. Just because we kind of want the variables last, I'm writing the L last. No. Well, we can do another one. Yeah, we'll get it. We'll get it. Yeah, your homework's like this. It's not that many problems because they are a little longer. All right. No, I told you guys. I'm sorry. I can't make the videos this week because of all this stuff. But by the next test, we'll get it back on track. Okay. All right. So let me give you another equation. V equals 48t squared. So, whoa. So what this represents is velocity. V is velocity. Do you guys want to guess what the t is? Yeah. So V, oh no, sorry, V is not velocity, I forgot. V is a vertical opposite leap in inches. So what this equation is going to tell us about is how high someone can jump given that they're in the air for a certain time. So T is the time in seconds. So this is called, it's hang time. It's the amount of time you're in the air when you jump. So like if a basketball player jumps to make a basket, you can calculate, if you know his vertical leap, how high he jumped, you could plug that in here and find out how long he was in the air, or opposite. Huh? Oh, that's a good question. We should experiment with that. You guys probably will do, I bet you'll do an experiment like that next year in physical science, too. Yeah, that would be fun. All right. All right, so in this one, we're going to solve for t. This one's actually a lot easier. So we're trying to get this t by itself. I want to know, what should I do first? Who is number 29? Piper. Do you have a guess, Piper? Nice. So let's get rid of that 48. So divide by 48 on each side. So we're left with t squared and v over 48. Now think about what you would do next. Don't say it out loud though. To get t by itself. We only have one more thing to do, really. Number 12. Who's number 12? Who is it? What is the number? 12? Jamie? Jamie, what do you think we should do to get t so it's alone and not t squared? Nice. Let's square root it. So now, you guys can all help me here. The square root of t squared is t, right? On this side, what's the problem with what we have as our answer right now? We have a square root of 48 in the denominator, yeah. So we can think of this as the square root of v over the square root of 48. If you want, we could get rid of that square root right now by rationalizing the denominator. What I would do, though, is let's simplify that square root before we rationalize it. So let's see. What gets us 48? What do you want to do? 24 and 2? How do you get 24? 12 and 2? How do you get 12? How do you get 6? That's a way to do it. That's fine. So let's see. We've got a pair and a pair. So those are perfect squares that come out. So what's going to come out on the outside total? 4, because 2 times 2 gives us a 4 on the outside. So we've got the square root of v over 4 root, who is stuck? 3. Nice. So we just simplified that square root of 48 by doing the tree and finding perfect squares. So now raise your hand, what do I need to do to get this rationalized? What do I multiply by, Jake? I don't even have to multiply by the 4, do I? Yeah, let's just multiply by root 3 over root 3. Do I have to do that to both sides? No. Is this changing this equation? No. It's just 1. I'm just multiplying by 1, so you don't have to do that to both sides. So, root 3 times root v is just root 3v. And what's root 3 times 4 root 3? 12, because it's 4, and then root 3 times root 3 is 3, so 4 times 3 is 12. There we go. Nice, no square roots in the denominator. All right, we got time. Good, I only want to do one more example. We got time for one more. Yeah, we still got 8 minutes, right? Yeah. All right. So on the third problem, let's see, I didn't write down what it was. Oh yeah, this is, okay, so this one is about throwing something down. Like if you went up to the top of the Grand Canyon and took a rock and threw it down. But you should never do that because there might be someone below you. So this is about throwing an object down. So in this one, we've got an equation. S equals 4.9t squared plus, okay, this is weird. It's not VOT, it's V sub 0. It's like a little teeny 0. It's like the opposite of a squared. It's down here. I'll tell you what they all mean. T. So it looks like VOT. You'll see this so much in your science class next year. So what they mean is if you take something like a rock, if we don't finish this because we were talking, I'm going to keep recording once you leave, and you're going to have to listen to it when you get home. And I'll check to make sure you did. Okay? So don't make us take too long. So if we are up and we throw a rock down, S represents the distance that it falls in meters. T is the time that it spends in the air in seconds. And V with a little O, and we call it V naught. I know it's weird. The little 0 means it's initial. So this is the initial velocity. Because it's going to depend on, like, how hard you throw the rock down. Right, Jake? It's going to depend on how hard you throw it down. So that V naught is, like, when it leaves your hand, how fast is it going? So you might drop it, like, kind of slow, or you might be like, really hard. All right. So we are going to solve for T. All right, we want to get t by itself. Ah, this looks like a yucky one, doesn't it? What do you guys see as a problem right now? There's a t here, there's a t here. What do we do to solve a problem? We have an x squared and an x. What do we get it equal to? 0, and then what do we do with it? It starts with an f. Factor it. So let's get this equal to 0. So we're going to have 4.9 t squared plus b naught t minus s equals 0. So I did that kind of quick. Do you guys see I just subtracted s from both sides, and I flipped the sides, because we kind of like to see it on that side. All right, so when we are solving a problem like this, we've got options. We can factor it. Do you guys think this is factorable? No, there's like 3 variables in here. We can complete the square. We don't even have a number here to complete the square, to divide it in half and square it. What's the third thing? It has a song. Quadratic formula. Yeah, Jack? It's just one number when you plug it in. So it's actually a 0, not a O. To let you know that it's the initial velocity, because sometimes you'll have a problem where you're going to plug in that velocity and maybe the velocity like 3 seconds into the situation. Right. I know, it does seem like they should use like a different letter. Shh. Oh yeah, sorry, 2A. But it's kind of just nicer to keep using v for velocity, because then you always know that it's velocity. So we're going to have to use a quadratic formula to solve this, all right? And if we don't get it done, you're going to have to watch this a little bit at home, all right? So let's figure out what our a, b, and c are. You guys, in this equation, what's my a? What's in front of the t squared? 4.9. Nice. What's my b? V naught is what it's called. V with a little 0. It's whatever the initial velocity is. It's whatever the initial velocity is. Maybe it's like 3.9 meters per second. That's how fast you threw it. And what's my C? Negative S. It's the whole thing right here, because this could have been like a -5 or something. So we're going to plug all this into our quadratic formula, and it's going to get us t, because t is kind of like our x, and the quadratic formula usually gets us x. So t equals negative b, so negative what? V, how do you call that thing? What do you call it? V naught, plus or minus the square root of b squared, so v naught squared, I know this is weird, minus 4 times 4.9 times negative s. Yeah, good. So we just multiplied a times c to put it right in there, all over 2a. What's 4.9 doubled? 9.8. You were close. So the only thing, honestly, that I would have you guys simplify about this is, let's figure out what -4 times -4.9 is. And I'm just going to look right here for the answer. It is 19.6. So we would just write t equals negative v naught plus or minus the square root of v naught squared v naught squared plus, right, because negative times negative, 19.6s all over 9.8. Yeah, so anytime you guys are trying to solve for a variable and you see, anytime you're trying to solve for a variable and you see it squared and a regular version of that variable, you're going to do quadratic formula, and that is like your x. Okay, so I expect you guys to try that tonight. I know these are like kind of messy and complicated. I expect you to try them. Okay, so tomorrow I'm going to be checking 2 homeworks, so you need to have those. Just a second, let me click this.